All right, let's get right into it. The tech world is buzzing about AI agents, right? These autonomous systems that can basically think and act for themselves. It sounds a little like sci-fi, but what if I told you we've been using the same core ideas for years? Well, today we're going to explore that really exciting future by taking a hard look at a powerful automation system we use right now.
This quote just hits the nail on the head. It really captures the moment we're in. For the longest time, AI has kind of been this passive thing. We ask it a question, it spits out an answer. We give it a prompt, it makes a picture. But the shift that's happening right now, it's a move away from those one-off tasks to something way more dynamic. We're talking about software that doesn't just respond, it actively goes after a goal.
And that brings us to the big question for this whole explainer. What if our software could be less of a tool that we have to command and more of a collaborator that actually gets our goals? Because that, right there, is what an agent is all about. It's not just some smart model. It's a complete system built around that model, giving it the power to plan, to use tools, and to actually act in the world to get stuff done. So let's properly introduce these things. AI agents are really the next logical step for large language models. They take all that incredible reasoning power and push it beyond just thinking to actually doing.
Okay, so to really understand what makes an agent tick, we need to pop the hood and look inside. Any autonomous agent, I don't care how complicated it is, can be broken down into three key parts. The easiest way to think about it is like a body. You need a brain, you need hands, and you need a nervous system to connect them.
So first up is the model, and that's the agent's brain. This is your core reasoning engine, usually a large language model. This is the part that does all the heavy lifting, all the thinking. It processes information, it weighs the different options, and it makes the final call on what to do next. But, a brain on its own isn't very useful if it can't interact with the world. And that's where tools come in. These are the hands. They're the mechanisms that connect all that thinking to the real world. A tool could be anything, really. An API that can check a stock price, a function that can send an email, or access to a database. They are literally what allows the agent to stop just thinking and start doing. And finally, the part that connects the brain to the hands, that's the orchestration layer, or the nervous system. This is the process that manages the whole operation. It takes a big, high-level goal, it breaks it down into a concrete plan, it manages the agent's memory, and it decides, okay, now's the time to think, and now's the time to act. It's the conductor for the entire symphony. So here's where it gets really cool. All these parts work together in this constant loop. It all starts with a mission. The agent then scans the scene to get context. It thinks through a plan, it takes an action with its tools, and then, this is key, it observes the result. That result gets fed right back into the loop, and the whole cycle starts again. Think, act, observe, over and over until the mission is complete. This is the fundamental engine that powers every single agentic system. Okay, so that's all the theory. You've got our brain, hands, and our nervous system all spinning in a loop. But that might still feel a bit abstract. So let's bring this down to earth with a real-world example of a really sophisticated, goal-driven automated system that a lot of us already use every day, a CI/CD pipeline. So how did these ideas, planning, using tools, executing a mission, actually show up in the tech we have right now? Well, the answer is probably a lot more familiar than you think, and it sits right at the very heart of how we build modern software. So let's meet our case study for today, Jenkins. For anyone who's not familiar, Jenkins is a hugely popular open-source automation server. Its entire reason for existing is to be an orchestrator for one very specific mission, taking a developer's code and getting it ready for the world all automatically. And this diagram just illustrates that mission perfectly. A developer pushes some new code to GitHub. That's the trigger. And from that one single event, this whole automated workflow just springs to life. Jenkins grabs the code, it builds it into an application, it pushes it to a registry, deploys it to a staging server, and then, finally, runs tests to make sure everything actually works. It's a really complex, multi-step process, all kicked off by one little thing. So let's take a closer look at how this automated system is actually built. As we check out its orchestrator, its tools, and its plan, I think you're going to start to see some really strong parallels to our AI agent. It all starts right here in the Jenkins dashboard. After a pretty quick setup, this thing becomes your central hub, your command center where you define and manage all of your automated workflows or jobs. This is basically where we give our system its mission. Now, here's a really important thing to get. Jenkins doesn't do all this work by itself. It acts as the orchestrator, and it uses a whole suite of specialized tools to get the job done. I mean, just like an AI agent uses tools to interact with the world, Jenkins uses tools like Git to get the code, Gradle to build it, Docker to package it up, and SonarQube to check its quality. Each one is like a specialized hand for a very specific task.
And how does the orchestrator know what to do and when to do it? Well, it follows a plan. In Jenkins, that plan is defined as code in a file called a Jenkins file. You don't even have to be a programmer to see what's going on here. This little snippet just defines a stage called compile, and the step is to run a command. The entire complex workflow is just a sequence of these stages, laid out in a script. And when the pipeline actually runs, Jenkins gives us this really nice visualization. We can literally see it executing each step of its plan right in order. First, it checks out the code, then it compiles it, then it runs the unit tests. It's just following the script, step by predictable step. And here's the full thing, from that initial code checkout all the way through packaging, building with Docker, deploying, and running the final acceptance tests. I mean, look at that, a complex end-to-end job finished with absolutely zero human intervention after that first trigger. This is a goal-oriented autonomous system in action.
All right, so we've looked at the theory of agents, and we've seen automation in practice. Now let's connect the dots and see how they're really two sides of the very same coin. And this right here is the aha moment. On the left, you've got our agentic problem-solving loop. On the right, the CI/CD pipeline. Just look at the mapping. It's incredible. The agent's mission? A developer pushes new code. Scanning the scene? Jenkins checks out that code. Thinking it through? It just follows that predefined plan in the Jenkins file. Taking action? It uses its tools to build, package, and deploy. And observing? It runs tests and reports the final status. It is the exact same loop.
This quote just reinforces the idea perfectly. Both of these systems, at their core, are all about managing a process. They assemble context, like the code and the plan, they take an action, they observe what happened, and then they use that result to figure out the next step. It's just this relentless loop, pushing toward a final goal.
When we look at the different levels of what agents can do, we can see a CI/CD pipeline is a perfect example of a level 1 connected problem solver. It's got an orchestrator, and it's got a set of tools to achieve a goal. But this pyramid kind of hints at what's coming next. Agents that can plan more dynamically, that can collaborate with each other, and maybe even evolve all on their own. So here it is, the key takeaway from all this. A CI/CD pipeline is a structured, deterministic, and incredibly reliable agentic system. It proves that autonomous systems can and do work robustly in the real world. The future isn't about replacing this kind of thing, it's about infusing this kind of rock-solid reliability with the flexible, dynamic reasoning of a powerful AI model. And that leaves us with a final thought to really chew on. For years, we've built these incredible automated systems to check our work for us. But what happens when we combine their reliability with an AI brain that can reason? What happens when our pipelines don't just test the code we write, but start writing and fixing it all on their own? That is the agentic future we are building towards.